Hello and welcome to a new video presented by Teleskop-Service. My name is Thorsten, and in this video I want to talk about the Ritchey-Chretien telescopes. So that's a real personal video for me because this is one of my favorite telescope types. I'm using a 12-inch Ritchey-Chretien by myself and I'm really happy with it. So that's the perfect opportunity to tell you some details about the whole series. So here in this video I focus on the brand GSO. We offer also Ritchey-Chretien from CFF, which is then a very high professional telescope series, mostly for clubs and let's say professional work. Okay, now without further ado, let's get started into some basics of the design. So what is a Ritchey-Chretien all about? First of all, it is a mirror telescope. We have two mirrors, one primary here in the back and one secondary here in the front. So light falling in the front, it's then reflected to the secondary and from there down here in the back to the focuser. This system is a mirror-only design, as you know from Newtonian telescopes, for example. The difference to Newtonian telescopes is the shape of the mirror. So we are using hyperbolical mirrors here in comparison to a parabolic and a flat with Newtonian telescopes. And the big advantage of this shape of mirror is that the field of view is pretty flat. So here the field of view is already usable out of the box. And this is also what makes this design perfect for, let's say, high-class professional and also very large telescopes. So for example, the Hubble Space Telescope is of Ritchey-Chretien design. Most of them are then a bit modified with a third mirror, but the basic principle is the same. So that design comes with some, I wouldn't say drawbacks, just with some facts or parameters. So the first thing is that secondary has to be in the exact specified distance from the primary. So there's only very little tolerance where you can move the secondary. And the secondary is bigger than you may know from other telescope designs. This is also because of the optics. The secondary has to be in a specific size and shape to provide that corrected field of view. Fortunately for astrophotography, what this telescope family is all about, the obstruction is not a real problem. For visual observing, that may not be the perfect choice because the obstruction is around 20 to 23% of the area, which is much higher than, for example, an optimized Newtonian, which is around 8% of obstruction. So it is usable for visual observing, of course. You have all the common standard things here, like the focuser, where you can put a zenith mirror and an eyepiece in it. But the intention of the design is to be used for photography. So let's check out the series from GSO a bit more in detail. So first of all, this table here that you can see is sorted by the size of the aperture of the mirror. The first one is the smallest one, the 6-inch, which I also have here in the background. This is just my standard travel telescope. That tube comes in metal or carbon. With carbon you have the advantage that you are not affected by temperature changes. Because of the long focal length, temperature change may be an issue with a metal tube. Alright, the next size in this list is the 8-inch. So this is 200mm diameter. This is now f8. So the common focal ratio for all the GSO models is f8. And this 8-inch version is maybe the most used one out in the world. It comes also in metal or carbon. You can decide what you prefer and what your budget is capable of. And then the next telescopes in the list, let me go a bit more in detail about the 10 and the 12-inch. So the 10-inch telescope is this one here, my example here on the desk. I will also peek into the details of the mechanical details, of course. But here you can also see the very first difference to the smaller models. Starting from 10-inch, you can get the telescope as a truss design. So that truss design makes the telescope not really lightweight, because you have aluminum plates here and also these carbon trusses. So in terms of weight, it's nearly the same, but it's more practical to have it this way, because you can access the mirrors without disassembling the telescope. So cleaning the mirrors is no issue at all, and that's pretty cool thing. And of course, it looks just fantastic. So the mechanical finish is really good. So no flaws here in the coating, and all these screws and threads are perfectly machined. So that's really nice design. And with the 14 and the bigger ones, 14-inch, 16 and 20-inch, you can get it only as a truss version, because then it's not really possible to manufacture a carbon tube rigid and large enough for these very big mirrors. With the 10 and the 12-inch, you have 3 options for the tube. You can choose a closed metal, closed carbon, or even this truss tube. So all depending on your budget and on your, let's say, preferences, what you like most. I personally prefer these truss tubes, but you can of course choose also a different one. So this 10-inch telescope here is, I would say, you can use it mobile. This should work, but it is already a bit heavy and also not so easy to carry around. I would say 10-inch, okay for mobile. A 12-inch, definitely not for mobile use. This is then really heavy, and also the bigger ones, the 14 and the 16-inch, are intended for stationary use in an observatory. In the future, this is just a sneak preview. I'm not sure when it will come, but in the future there may be also a 20-inch Ritchey-Chretien from GSO. So this is then 500mm mirror diameter, which is a really large telescope. This is then, let's say, for bigger observatories, and will also give you fantastic image. Regarding the price, this is really a good, it's just a good deal. Now let's check out the mechanical components here a bit more in detail. So I explained it to you with the truss version, but it applies the same for metal and carbon tube mostly. Maybe we start here in the front. So first of all, we have that thick secondary spider. It appears a bit thick, but it is needed to carry and to hold that secondary here in place properly. So here's nothing moves here. That is really good machined, all matte black. And here in the front, also important, there are the collimation screws for the secondary. Regarding collimation, please keep an eye out for another video coming up where I use a collimating telescope for collimating this Ritchey-Chretien. So the best way is to subscribe to this channel, and then you get notified about this next video if you're interested in collimating the RCs. We have here, when we go to the primary, first we have here that baffle, that light, central light baffle. This is important to block stray light or false light from hitting the sensor. Here in the back, the primary mirror. And this mirror lies in a 6-point cell, so a very rigid cell that can hold that primary mirror properly. Here on the lower end we have 2 dovetails mounted. With the 10-inch and larger, these are 3-inch Los Mandi style dovetails. So here you can see them. So with 2 of them, the lower is used to mount it on your equatorial mount, and the second is to be able to put some more equipment on top, maybe a smaller refractor if you want to have a wide field setup. Then you can put this with a second clamp here on the top. Okay, now let's rotate it. Okay, and here in the back we have that huge plate, that huge back plate, 10mm aluminum, also with collimation screws here, sets of collimation screws. And here are also fans integrated. 3 fans that can be powered by batteries or by a power supply. That will just help to create some airflow here through that little tube to help to cool down the mirror more quickly. Yeah, and last but not least, here we have the focuser. The standard focuser is a Crayfoot style. Here a 3-inch Crayfoot focuser. This is the standard for these Ritchey-Chrétiens, and they are good for all, let's say, starting work, for visual observing. They're great, no problems with that. It has a micro reduction here, 1/10 reduction for very precise focusing. And it's also equipable with a motor focuser if you want. Alright, so this is all about the telescope itself. I want to tell you some more details. First of all, let's talk about the focal ratio. This is f8 native focal ratio, and this is considered slow in terms of astrophotography. You have to integrate pretty long time. For example, if you have a f4 Newtonian, which is much faster, then you can integrate shorter time. It is by design that this is f8, but you have 2 options. You can use a reducer, which gives you a focal ratio of f5.6. This is already pretty good. This is definitely worth trying out, because this reducer, this is a 2-inch reducer, is also pretty cheap in comparison to other ones, and it can illuminate up to a APS-C sensor. So this is definitely the limit of this reducer, but if the telescope is properly adjusted, properly collimated, then you can use it up to APS-C. And this reducer also has a working distance of 85mm. This is pretty large in comparison, for example, with coma correctors. So you can put a lot of equipment in between, filter wheel, rotator, off-axis guider, everything is possible. But you can, of course, also use only spacers and a filter drawer, for example. So this is all up to you to decide what your preferred imaging train then is. If you want to go, let's say, bigger, let's say you want to use a full-frame camera, then I can recommend the TS-RC Red. This is a 3-inch reducer and corrector, so it also corrects the field a bit, and that gives you pinpoint stars up to the corners of the full-frame sensor. So also the illumination is pretty good, so you should always do flat frames, but the illumination is very uniform and no real problem. And this reducer is then also screwed into the tube with an adapter, and that saves a lot of backspace. So that's a really nice thing to have also as said if you want to use big cameras. That reducer and corrector gives you a reduction factor of 0.8, so this is then around f6.4 focal ratio. So, and this is also the reducer I'm using most currently with a ZWO full frame camera, and that's working flawless, give very nice results. Talking about cameras, when you use the telescope, let's say with small cameras, lightweight cameras, OSC for example, then this focuser is more than enough. This is no problem. But if you want to use big equipment like filter wheel or rotator, then I would highly recommend upgrading that focuser with a rack and pinion style. For example, we have the TS-Optics R30. That's a very nice replacement for the original one, and that can carry up to around 6 kg of camera load, also equipable with a motor focuser. This is then a really good choice. And because these components are most used together, we also packed these 3 components together in one pack. So you can order this combination, the setup, as TS-RC1064. And this is the combination, and this is also available as 12-inch version. So then you have all in one order, one box, and you're ready to go with a very high-class setup. two more optimizations I want to recommend to you. The first one, I mentioned this, let me just turn it around again. I mentioned that central bevel here. So this bevel is designed and optimized for visual use and small sensors, small camera sensors. If you have a setup like this, that's working. No problem, no worries. But if you use a full frame camera, then it can happen that false light is hitting the sensor. And this is by light which is directly hitting the sensor, and it's not reflected by the mirrors. So it's not hitting directly the sensor, it's more or less reflected, and then you get weird rainbow-like shapes in the corners. That's a real issue. Especially with full frame cameras you will face this problem, but there's a very simple solution for that. You can also order a thing like this. So this is just a, let's say a plastic cap which comes onto the original bevel, and it just extends the original bevel by, I would say 5 centimeters or so, and this will now block these false light from hitting the sensor. Very simple solution for that issue, and it is not affecting the image very much. Maybe the vignetting is increased very slightly by some percent, but it's really not really visible and will definitely calibrate away with flat frames. Okay, the last thing that I want to show you is this light shroud here. With these truss tubes you have the problem that light may hit the mirrors from the back. For example, if you point it somewhere in the sky and you have, let's say, a power supply with an LED on the ground or something like this, just some weird artificial light from somewhere, a street lamp or something, which may hit the primary or the secondary here from the side. This will not happen with closed tubes, but with these truss tubes that can happen, and it will ruin your image, and it will also change when the telescope moves, so you can't calibrate this away. But therefore you can use this light shroud here. This is just prepared fabric. So here are adjustable rubber bands integrated. With them you can adjust and fix this light shroud here in place. So it's not very affected by wind because it's lightweight fabric where the wind can just go through. So that's pretty nice to have, and it will block this artificial let's say artificial light from the sides. A third thing just to mention is a secondary heater. Under very humid environment you may have the issue that the secondary will just collect dew. And to avoid this you can also add a secondary heater here in the front. I personally never needed one because I have it stationary in an observatory, so there the dew is collected on the outside of the dome. But if you are in the field, that may be an issue, and a secondary heater may help. Alright, that's it. That's what I want to say about the Ritchey-Chretien series. But here in the end, as I mentioned, it is a bit special for me. In the end I will do a little showcase, just show you some images I took with a Ritchey-Chretien telescope. Just for you to get an idea what you can achieve, but you can of course achieve even more. Depending on your sky, the target and the equipment. So I hope you enjoy the upcoming photos from me, and I hope you see you next time. Thank you very much, and bye bye.